So our next session is starting, and I'll leave it to Dio to start the proceedings.
Yes, thank you. Good afternoon. Can you have the slides, please? Rebecca, Dorothy, could you confirm if you can hear us?
Yeah, you're loud. Thank you.
Yep.
Great, thank you. Yeah, fantastic. So, yeah, honored to lead this session on local sensors for smart air quality monitoring in African cities. Session co-leads, that's myself, Dr. Ahmed, engineer, Bainomugisha. We are all here in person. Next slide. Yeah, so I'm going to start by giving an overview of the session. Next slide, please. Yeah, I think a lot has been said, so at the risk of repeating myself, just to emphasize that we need timely, accurate data. I need to add accessible to be able to address the pollution problem in the cities. But we know there's an elephant in the room, which is how to be able to get that data. You need to have a high resolution network, and that can be very costly. So if you're trying to say we want to use the local sensors, which present immense opportunities, it means a lot needs to be done. We need to answer all the questions, whether it's quality assurance, whether it's the cost of setting up the network, or it's the capacity to make that happen. We need that conversation to happen, and we need to be able to co-create this solution. We need to be able to co-design. So this is what the session is about, is to explore how we can make local sensors work in the African setting. So we invited abstracts with a very specific focus on sensor development, smart calibration of large-scale sensor networks. We want to migrate from pilots to action networks, data transmission, digital solutions, maintenance, data sharing, and so on and so on. So very specifically, the session is tailored really to achieve three key outcomes. Firstly, increasing understanding of cloud-based and custom digital solutions for network management, quality assurance, and data access. Unlocking the enablers, this is key, of data sharing to foster collaborations amongst all of us, potential data providers. And lastly, and not least, is really to contribute to building consensus on the best practices. I think this has been talked about a lot. Best practices for scaling up all the work that we are doing, sensor development and deployment. Quick housekeeping, this is being recorded. I think we all know this. I've got 3-4 moderators, so it's quite a fairly packed session. That's joining virtually. Then, of course, we'll share these resources. The Q&A, Mrs. Taylor has panel discussion, so really pretty much a discussion of moderators. I'll skip this. But also just to acknowledge, of course, the efforts are going to put it together, the session. Yes, it looks like I'm moving the slides for myself, but not for the audience. Could you carry on? Next. Yes, this is where I am. Yeah, just to acknowledge everyone who is involved in the session in various capacities, whether as moderators, lead, or speaker. So I want to go through all that. Hopefully, the branding there are recognizable. Next. Yeah, I'm going to spend strictly 3 minutes to just introduce the moderators. Professor Rebecca Garland, who is not a stranger to atmospheric science. She's an associate professor at the University of Pretoria and a member of the advisory panel of the CCSC, Climate and Clean Air Coalition, and the Scientific Steering Committee for ANGA, and the founding member of the ANGA network. I'm just trying to go really fast, and she's joining us virtually. Dorothy, brilliant moderator, PhD student at the University of Wisconsin, Madison. That's the Nelson Institute for Environmental Studies at the University of at UW Madison. She also teaches an undergraduate program, a capstone program that she designed on air quality and equity in an African city, of course, with a case study in Kampala. Victor, who is here physically. Victor, can you show yourself? You may as well take your seat. So Victor is a consulting research fellow at HEI with more than 8 years experience in environmental health and pollution control in low and middle income countries in Africa. And with extensive experience in environmental monitoring, policy violation, contributes expertise to various initiatives. I'm sure many of you, of course, are familiar with Victor. So just go straight. Engineer will help us to do a recap of the session if the time permits. Engineer is a professor and chair of computer science at Makerere University, and also leads the AirQo initiative alongside several other impact initiatives. He's passionate about contributing to quality computer science education that's sufficient to the breadth and depth of practical and fast, breadth and depth, practical and fast enough. He has been named the 2022 Global Leaders to Watch by Google. And yeah, honored to have him with us as well. Lastly, and I'm jumping out shortly, this is the session outline. We'll have the big picture perspectives moderated by Rebecca. That would be Subru as a recorded presentation and Dr. Alani. Then we'll have progressive case studies. Will be moderated by Dorothy. Then panel discussion, that's Victor and Thusi. And then general recap. So yeah, time is key, and I'm going to be the timekeeper. So without much ado, I want to hand over to Rebecca to take us through the first. Could you, previous slide, please? Yes. Rebecca, over to you.
Great. No, thank you very much. I'm sorry I can't be there in person, but I'm glad to join you all virtually for this really exciting session. So the first talk, as Deo said, will be recorded. It's from Subbu, who leads a 20-person strong air quality group in a think tank in Bengaluru, India. And he's also a research fellow at the Kigali Collaborative Research Center in Rwanda and an adjunct professor at Carnegie Mellon University, USA. And he'll be talking about the global perspective. So I think I'll hand over to tech support in the room to start the recorded talk, please.
Good afternoon, everyone. Thank you for this opportunity to share some of the learnings from the last several years of air quality monitoring in the US and in multiple countries across Africa. I'm currently at the Center for Study of Science, Technology and Policy in Bangalore, India, and I'm of course closely affiliated with AfriqAir. Our story begins in 2015 when we collaborated with Senseware, a small startup in Pittsburgh, to develop the ramp. Senseware already manufactured industrial sensors, and so developing the ramp box was a natural fit for them. They also had easy access to imported hardware parts. So from concept to the first prototype took them only a couple of months. And after Albert and I evaluated the ramp against our reference monitors for a few months, we had a production run of the ramps running in early 2016. And by 2017, we had 50 nodes running across the Pittsburgh area. We were also collaborating with the Allegheny County Health Department, which runs the regulatory monitoring network in Pittsburgh. We initially co-located our sensors with the reference monitor at Carnegie Mellon, but over time, we shifted those co-locations to the ACHD stations. ACHD was very kind to allow us that facility because they had well-maintained reference monitors, and so that took quite a load off our shoulders. The 50-node ramp network, of course, the data was transmitted over SIM cards purchased from Amazon, so that was easy. We stored the data in an AWS server that was set up by Senseware, and this was just the raw, uncorrected data. Carnegie Mellon students developed codes to download, clean, and archive the data. Finally, Carnegie Mellon postdocs like Naomi Zimmerman and Carl Mallings and graduate students like Rebecca Tanzer and Rose Eilenberg analyzed the data and produced the science from all of these sensors. We also partnered with engaged local communities who are very keen to monitor air pollution in the neighborhoods. And all of this work was funded by the US EPA and the Heinz endowments. So this is an example of a very well-resourced project. We had a lot of advantages going in. And so now I'll contrast this experience with our work in Africa. We started monitoring air quality in Kigali in 2017. And Safari, who spoke yesterday, and Valerian, Claver, and Sandrine helped install the monitors at the University of Rwanda campus. We also installed monitors at a couple of colleagues who were living in Kigali while working at the CMU Rwanda campus. Now it's the CMU Africa campus, as it's called. We collaborated with Jimmy Gasore and Langley Dewitt, who also helped us locate one of the sensors at the Rwanda Climate Observatory. We did not have a reference monitor for PM at that time in Rwanda. And so, but actually the Kalisa was collecting filter-based samples for a certain number of days that overlapped with our study. And so we corrected our data using this filter-based PM 2.5 values. We were able to publish these results, which is the first 16-month-long study of air pollution in Kigali in the Clean Air Journal. In 2019, we had an opportunity to deploy a 20+ Clarity node network in Nairobi through a collaboration between Emilia Turnstone, Dan Westervelt, Faye McNeil, Albert Presto, Paulina Jaramillo, and myself. Clarity, of course, provides the connectivity and the data management for these sensors, as well as the solar panel that powers these sensors. Professor Michael Gattari allowed us to collocate some of the sensors with his BAM. So collocation with the University of Nairobi BAM was very important for quality assurance of these data. And Professor Gattari's master's student, Ezekiel Waiguru, joined us in France to do his PhD, and he's using this data as part of his PhD studies. We have similar experiences working with Kofi Omega in Ghana and Veronique Yeboye in Cote d'Ivoire. So what are the lessons we have learned from these years of measurements? First, low-cost sensors through the advantage of mass manufacturing are lower in price, and this can also lead to inter-sensor precision. But we need to verify this by collocating the sensors with each other for 2 to 4 weeks before we deploy the sensors across a network. Number 2, the data do need to be calibrated or corrected to reference values by collocation. That still remains the one method that is accepted and tried and tested. We initially started with individual calibration models for each of the ramps, but once we had 50 or 70 ramps, this was getting tedious and untenable. So Carl Malings came along and developed a generalized calibration model that used the median response of a set of collocated ramps to develop a calibration model for all the ramps. Now, this had 2 advantages. One, we just had to develop one model for each specific configuration of the ramp. So instead of 70 models, we had maybe 5 or 6 models because the sensors varied with each ramps, with some of the ramps. Number 2, the generalized calibration model showed better performance when moving from site to site, whereas individual calibration models, because of the machine learning algorithms used to correct the gas sensor data, could be overfitted and thus not perform as well when shifted from the original collocation site to another site within the city. Number 2, we can use what is called a golden sensor that is permanently collocated with the reference monitor, and that is the typical sensor that behaves similarly to all other sensors, and this way we can track lifetime performance, including drift and sensor failure by comparison to the reference data at that site. But again, this assumes that the sensor actually behaves similar to the other sensors in the network, which which can be verified to some extent with the initial collocation. Now, there are other methods, field-based methods to correct sensor network data, but they may assume spatial and temporal patterns. And when we're deploying sensors in a new city, we do not know what the spatial and temporal patterns are necessarily. And so if we assume a certain spatial and temporal pattern in our calibration methodology, then we may predetermine the results that we seek to investigate through the deployment of these sensors. So I am generally not in favor of such methods. Finally, many countries even today lack reference monitors or easy access to reference monitors. And so the AfriSet and Northwest University sensor evaluation facilities that we heard about yesterday are a step towards providing basic regional QA. And this is an important effort, and we hope that more such centers are established in different parts of the world, including different parts of Africa. The challenges are that these are still expensive reference instruments, both to buy and to maintain. And so we do need government agencies and philanthropic agencies to step up and enable that such purchases and continued operations are funded appropriately. Now, there are some practical challenges when deploying the sensors, of course. Many of these key components, optical and electrochemical sensors, are imported. While some countries may exempt university research equipment from import duties and taxes, that often involves significant paperwork and delays the deployment of the sensors. Now, Rwanda exempts reference monitors and sensors from import taxes, so hopefully other countries can adopt similar policies. That would be really helpful. The data transmission continues to be over international IoT networks. The challenge is that GSM modules developed in the US and EU do not always work in African countries. So we do need to spend a lot of time configuring and troubleshooting this GSM modules in the target city or country. And even then, the GSM module may not work. So we do need local IoT networks to overcome this hurdle. Finally, long power outages are common in many parts of the world, including especially in Lagos, as we recently found out through our work with Professor Alani. Solar-powered sensors can help, but if there is continued outages and there are cloudy and rainy days, your battery runs out and your solar power cannot be charged. And so this is the time when people often use polluting generators, and we are unable to measure this pollution. So what do we do? Some of the lessons that we have learned, of course, are that we need more power efficient sensors and data transmission modules so that our power energy demands are reduced. We need better IoT data networks so that even if there is a network outage, the stored data that's stored on the hardware, on the sensor node itself, can then be transmitted when the network connectivity is restored. Now, there is some basic data archival that we do currently, but real-time diagnostics and real-time insightful visualizations still remain a challenge. In that vein, the Clean Air Fund recently released a report about an open source DMS, data management system, and we hope to work towards that as part of a new project we are starting at CSTEP when deploying a multi-pollutant sensor network across Bangalore. And we are open to collaborations with other parties on that front as well. Now, finally, governments could lower monitoring costs by eliminating import duties and recognizing that air pollution research is important towards reducing this public health risk. This, I think, is something that should be taken up on a priority basis. And on that note, I welcome you to attend our Thursday 1:45 p.m. session on mobilizing resources to support air quality monitoring research in Africa. Finally, I express my gratitude to my collaborators, Kofi Omega, Alison Hughes, Rose Alani, Michael Gattari, Jimmy Gasore, Becky Garland, Veronique Boye, and many, many more. Mike Giordano and Dan Westerveld are there, of course, with you guys. And I wish I could be there. I regret my inability to attend in person, and thank you all for this opportunity.
Great, thank you very much to Subu, wherever he is from afar. Thanks for that very interesting talk on more global perspectives from Pittsburgh to many countries across Africa. We'll now move on to Dr. Rose Alani, who is there in person. And I believe Subu has just joined us virtually. So thank you for your talk. So Dr. Alani is an associate professor at the University of Lagos in Nigeria and has 17 years of experience in teaching and research work on environmental and analytical chemistry, particularly with air pollution, climate change, and environmental sustainable research. And she leads the Air Quality Monitoring Research Group at the University of Lagos, and she's also a fellow at the EU EPIN and EESKT-TECEBCEM, a key initiative of the Federal Ministry of Science, Technology, and Innovation in Nigeria. And as we heard from Suba's talk, they've also worked together. So Dr. Alani, I'd like to hand it over to you to discuss the more regional perspectives. Thank you.
Thank you, Rebecca. So good afternoon, everyone. So I want to go straight to my presentation. We'll look at the issues, logistics, access to funds for local census acquisition. Air quality funding commitments are not enough to combat the scale of the problem and are also declining. In 2020, international development funders cut their commitment to air quality projects in half, and the trend is continuing in 2021 based on preliminary data. So as you can see there, the funding 2015 was low, went up, down, up, and then 2020 went down. And so with this pattern, what do we do? How do we get our projects funded? Can we go to the next slide? So how do we then access funds? I've listed some points here that I believe will really help, that has helped me. So in your research, be passionate about problem solving. That's the first thing. Do not put money first so you can gain some visibility. I think gaining visibility is good first. Then collaboration makes funding access much easier. Search for grants, apply both on individual basis and also jointly. So when applying jointly, it's better to allow an experienced partner to lead for a higher chance of winning. I put that particular point because I had some experience last year collaborating with someone, and then we tried to apply for the project, for the grant. And so the person insisted it has to be his university, and I couldn't force it. So I just said, okay. I think Dio is also aware of that. Dio tried to tell him, no, it shouldn't be your university. He said, no, it should be his own. So we both just had to keep quiet, and we just went along with him. And that complaint came that it shouldn't be your university. And so we did not get that grant funded. So watch out for your government internal research grants. For instance, in Nigeria, we have what is called TED Fund grant, tertiary education grant, which can support air quality projects and so on. Membership of air quality monitoring networks is very important. For instance, CAMS-NET, AfriqAir, and ANGA, and AfriqAir that was just announced not long ago. So that makes it easy. If you belong to a group like that, you'll be able to know, have information of calls that are available, and then you'll be able to have experts, those that can fill in to where you're not able to to fill in. So with this point, I think it's easy. And also collaborating with government agency is also important. Your environmental protection agencies in your country, collaborating is also good. Now, still on the logistics, want to look at the prohibitory tax regimes. That's a setback. For instance, some countries can apply for tax exemption, but some can't. For if you get monitors donated to you, even donations, some countries will not allow you to get it free, except you pay huge customs duties. And that happens to me also. It's happening in Nigeria. So there are some countries that can waive because it's for education purpose. And so that's an issue. Also, experience with some manufacturers of local sensors in Nigeria who could not bring in batteries for their sensors because they had to pay heavily bringing in batteries. And so you have to go and couple before bringing in. So those are setbacks. Okay. Can you move? Next slide. So local infrastructure, want to look at that. Unreliable power is a restriction on choice of local sensors. Those places that have epileptic power supplies, like in some of our African countries, it's a serious setback where you need to plug in. There are some sensors that you need to plug into the mains, and when you cannot have power constant, it means when you lose those hours, you lose your data. And so that's a shortfall. And some other local sensors that have provision for solar panels, yes, those ones are okay. But there are some locations also that you might not have enough sun, but real location where you should monitor, but you don't have enough solar power, enough sun. Then alternative should have been electricity, but you don't also have. And so that's a setback. Yes. Another slide, next slide. So also internet connectivity is another point that there are locations that you don't have internet access. And so to be able to get your data to the cloud, you need internet. And so before you get your local sensors, you have to be sure that the connectivity, that you have connectivity, and the technology is available for either cellular, Wi-Fi, and so on. But so if you don't have connectivity, you don't have Wi-Fi, you don't have GSM, or you have Wi-Fi and it's not working at the location that you're deploying. And so those are also issues. So some offer just one option. I'm talking of the local sensors, option of Wi-Fi. Some will, offer this option of GSM and so on. So network availability is also a problem. And if supplying your own mobile hotspot also, you may have to also know that a typical data use, know the typical data use, and if a sensor setting can be adjusted to reduce the data use. If you're using your own hotspot, it's another issue. If your own network is not working well, then you will not be able to collect the data. So all those are problems that we encounter. Those are some challenges that we encounter. So here is one of the low cost sensors that I used, called Air Quality Egg. Air Quality Egg is Wi-Fi enabled, and it needs to be plugged into power, electricity. It comes just like that without any other power source. So in this case, what we did is that we had to get solar panel, got external battery, got a charge controller, and connect them together, and then got a Wi-Fi. So to monitor using the Air Quality Egg, you have to get all those things connected for you to be able to access your data. And one good thing with that device is that one can move around with it, maybe in a scene of something happens, maybe the fire incidents, one can move it there and then monitor and check, but you have to move with all those things. You have to move with the solar panel, with the battery, with the Wi-Fi and everything, except the laptop. So, and example of the monitoring we did using Air Quality Egg is that one, that picture down there. It happened last year, June in Abuja. So you can see the solar panel there. You can see the Air Quality Egg on that green seat, and all the other things are there behind. And so that's how we monitored. So we monitored at 4 different locations in Abuja. We monitored at the Secretariat, where we have the Federal Ministry of Science, Technology, and Innovation. We monitored at another location called Apo, and also Gwarimpa, and also a place called New Yaya, that is suburban area. So we discovered that what we did not expect was what we discovered, because we did not expect much from that suburban area, but we got a lot at that place. And so we're able to go back and trace to know what actually happened. And we could see that they have very poor electricity supply, and they were using a lot of generators. So in setting up and maintaining sensor network, you need to start with stakeholders engagement. So this will help. First thing, you have to map your stakeholders, identify those people that are really key in this. And so those are the people to help to map the locations for deploying the sensors. It's very important to work in teams. Teamwork is very necessary. So this team you see here is some of my air quality monitoring research group members when we're discussing and trying to look to map some locations for deploying AirQo sensors. And this other team here is made up of the air quality monitoring group members, LACEPA members, and so on. And this is my my Abuja team, which is still intact. Okay, for quality assurance, you need to co-locate your local sensor with a reference monitor to validate, calibrate, validate it, and know that the data is of good quality. And you can locate directly with the reference monitor, and you can also co-locate the local sensors with each other. And so because you need to compare the data sets, it's important that the devices measure, that the devices are co-located under the same condition with the reference monitor. And it's also important that they measure under the exact same conditions. So for instance, if you have, or also measure the exact pollutants you're looking for, you might have reference monitor that can only monitor PMs, and then you have local sensors that are monitoring gases. You will not be able to co-locate such. So thank you for listening.
Great, thank you. Thank you, Dr. Alani, for a really insightful and interesting talk. So I'm going to just do a quick wrap up and then hand on to the next session. I think the start was really interesting to show some of the real specific challenges with both LCS, but also the larger enabling environment, such as import taxes, right? A wide range that would need to change to have smart air quality monitoring in African cities, as the title of the session notes. And so I do know we're moving on to some research that has shown how people are addressing some of these challenges. But I did also want to note that I think it was great, both of the speakers highlighted that despite these challenges, the great work that is happening and the real importance of networks and working together and collaborative and how we can move forward together. Something near and dear to my heart. So I think that was really interesting to highlight that. With that, as I said, we'll save questions, I think, to the panel discussion, since we started the session just a little bit late. I'll hand over to our next moderator, Dorthy.
Good afternoon, Diana, and I'm very happy to be on this panel as a moderator. I'm speaking from US University of Madison. And our next session is about progressive studies, case studies, and we're going to hear from Usama, Gideon, and Gideon and Okedi. But to start us off, we're going to have Usman Ahmed, and we're looking at the life cycle of local sensor networks for air quality data in African cities. Usman Ahmed is a mechatronics engineer with a passion for robotics and experience in automation, IoT, CAD design, and hardware implementation. You can find Usman on his X handle at Usman Mbu or on LinkedIn. And so I'm handing it over to you, Usman. We're glad to have you on this panel.
Oh, thank you very much. Hello, everyone. My name is Usman, as she has said, and I'll be working through the life cycle of local sensor networks for air quality data in African cities. All right, in this presentation, we'll explore the comprehensive life cycle of air quality networks. It's not really going to be technical, but we'll try to touch on most of the key considerations you should put in place when you are thinking of setting up a network of sensors in Africa. Okay, first things first, you need to define your objectives. You need to know what you want to measure. Is it PM 2.5, PM 1, or PM 10? Or are you talking about gases, or are you talking about solar radiation and the likes? Then after that, you tend to identify your locations when you want to have those sensors. Here's a map here. We worked with this at Sensors.AFRICA, and we selected locations where we wanted to have our sensors. And this also helps you in mapping out the stakeholders. Once you have a place where you want to have your sensor, then you can easily decide who you are meant to interact with to make sure those sensors are placed there. Then you create a work plan. This helps you track your progress, know how far you've gone, what you've done, and what you're here to do. Okay, next, you have to understand the African environment. We have large, beautiful cities where everything is in place, and we also have a lot of places and environments where a lot of these things might be missing. So you have to make sure you know how the infrastructure is, accessibility, connectivity, power, and the climate conditions. We have some communities here that you cannot access by roads. You have to go on a ferry or on a boat. And yeah, when you're making decisions on this, it influences your operational costs, procedures, and your systems. Then you should consider hospitality. There are some communities where they are very welcoming. It's easy for you to go in there and have your sensors set up. They would even reach out to you to let you know that your sensors are faulty and they've tried troubleshooting, but they need your help. And there are some communities where you would have to actually seek approval before you can go into the communities. And you would also need a guide. You can't just walk in there to work on your sensors or anything like that. Yeah, next, weather. Yeah, weather impacts our sensors a lot. You need to know the weather map of the region, how much rain are you expecting, how much sunlight, what are the temperature readings you're expecting there, because this affects the kind of sensor you would have and the kind of materials you use for your sensors if you're going to build one by yourself. Then, yeah, so you would want a sensor that would not easily degrade based on the climatic conditions we have here in Africa. You know, temperatures are a bit different from what you have in the global north. And yeah, you also have to make sure that your sensors, if you are buying from manufacturers or getting it from elsewhere, make sure that the operating conditions actually fall within the conditions you are expecting to meet where you want to have your sensors. That's in Africa here. Yeah, this is a heat map of Africa. It's quite old, from showing the average maximum and minimum temperatures between the time of 1961 to 1990. It's not so clear, but from what I have here, if you have sensors that work within 0 to about 40 degrees, that's fine. It will serve your needs. However, this is old, but we know that global warming is ongoing and a lot of these temperatures are expected to have risen. Yeah, power. That's another huge issue we're facing in quite a lot of places, and in other places, that's not an issue. So you have to consider the energy landscape wherever you want to have your sensors put and tailor your choices based on them. Have backup batteries, and yeah, that will last you quite a while, and make sure your systems are low powered. They don't actually require a lot of power to operate. That way your batteries can last longer, and you could have solar panels, but whenever it's kind of rainy or cloudy, yeah, you might not get enough sunlight to charge your batteries, and that means you would lose a lot of data. Just picture having about 20 sensors in Accra and it's like cloudy for 2-3 days. You'll be losing data for maybe a day or two, and that's not something nice. Yeah, here's a map showing access to electricity in Africa. This is as old as 2019, but still usable. You can see not a lot of places have up to 90% coverage for electricity, and a lot of them fall between 50 to 60 to 70. Then quite a few are less than 10. Yeah, communication mode. Yeah, select a mode that works for your locality or where you want to have your sensors. You could talk of Wi-Fi, you could talk of GSM, NB-IoT, Sigfox. There are a lot of systems out there, but try and map out your locations, know what you have and what you don't have. That would help you decide on what to use. Then you could also adapt multiple modes. You don't have to just stick with maybe Wi-Fi or GSM. You could have both, and you could also have a memory card. Yeah, you could load your data directly in them, and maybe when you use your GSM or your Wi-Fi connectivity, your data is logged there, you don't lose data. And once connectivity comes back, you can transmit your data. Or if you can afford to always go and pick out the memory cards and download your data from them, that's another option. All depends on you. Yeah, component procurement and logistics. Yeah, it's quite a headache for us over here. Talking about how much time it will take for your items to be shipped. Once they are shipped, customs, a lot of levies you have to pay, and it's a huge headache. And not to talk of regulations from the government. You might need some approvals, some certifications, and one way you could actually go around it is to seek for locally available parts. Yeah, things that are available over here in Africa, where you could just walk into the store and buy them. You can't get all your components or parts here in Africa, but there's a lot you can get, and that helps because that means someone is taking away the headache of having to wait so long to get your components or your parts, or having to pay custom duties and the like. Someone has done it for you, so that's a lot of problem taken off your table. Yeah, these are some local sensors. We've seen a lot of them already. Next, please. Yeah, now let's go to the second part. That's deployment, monitoring, and maintenance. You've done your planning, and with more work and research, you should be able to have your sensors and already. It comes to you deploying and monitoring them, maintaining those sensors. You should consider theft prevention, vandalism, sunlight exposure. That's if you're going to be using solar panels. It's very helpful to consider where you mount your sensors. Make sure that it has direct access to sunlight so you don't be losing power or data due to downtime from lack of power. Then where you host your sensors, where you place them is also very important. If you're looking for ambient measurements, you shouldn't put your sensors too close to the pollution source, except that is what you're really interested in getting. Or take, for instance, huge apartments where there are a lot of air conditioning units outside, and you know those areas tend to be warm. Placing your sensors there would give you biased readings. You should not be expecting to get ambient temperature readings when your sensors are too close to them. Then try and do site visits. It's not always possible, but it's recommended when you can. You do that, so you have a look at where you want to place your sensors, and that helps you plan accordingly. Yeah, monitoring and maintenance. Yeah, you need to implement monitoring systems for detecting downtime. That's when your sensors are offline. There are a lot of tools you could use, Grafana, and you could also just maybe, if you're not so big, manually load some scripts that would show you when your sensors are offline. It could be on a daily basis, a weekly basis, or the likes. Then plan maintenance schedules. It could be preventive, which is very good, or predictive if you have the data and the capacity for that, or collective. That is when you know your sensors are actually offline. And yeah, for this, data is very important. Try to make sure you log when your sensors have been offline, or look at your data, the data coming from the sensors. They help you decide when your sensors are faulty or working fine. From this graph here, you can see the image on the left is from a faulty sensor, while the one on the right is from one that's working fine. You can see from looking at this, you know something's wrong with the one on the left. That is due to the readings you are seeing. That's over 4,000 microns for daily averages each day, and that's bad. And it was odd for us because this was the second month we had the sensor out there, and it wasn't supposed to happen. Yeah, decommissioning and proper disposal. Yeah, you have to consider the lifespan of your sensors. A lot of manufacturers out there actually recommend how long you're expected to use these sensors, and you have to take note of that. Plan for maintenance, replacements based on the manufacturer's recommendations. And once you are done with that, whatever you take out, make sure you dispose of it responsibly. There's a lot of e-waste out there, and we're really trying to cut down on those. And we're all about the environment, so why pollute it more? Now, community involvement, yeah, this is something a lot of people have spoken about. Here are my few takeaways from it. Engage them so they have a sense of ownership. It helps you actually secure your sensors, you know, it's safe. And they could also be involved in maintaining your sensors. Whenever you have downtime or you need to do some basic maintenance of your sensors, you don't always have to go to the sites for them. You could reach out to members of the community to assist with that. And in return, there are many other things you could do. You could have sessions with them, share your skills, share your data with them, let them know that there's something coming out of the sensors, share your reports. Don't just give them the raw data. They might not understand that, but try to visualize it for them, let them have it and understand what's going on. So in summary, when you're developing a local sensor network, think of it as an entire system. Don't just think about how you're going to place the sensors. Think about it from your inception, the plans you have, and every other thing you have to put in place. And this will ensure you have an effective and a sustainable sensor network in Africa. Oh yeah, this is Code for Africa. You can join us, find us on Twitter. You can join our Slack team, and we'll be opening a sensors community. And for that, you can just scan the barcode on the next page to join our community. Thank you very much.
All right, thank you so much, Ahmed. Moving on very quickly to our next panelist, we have Gideon Maina, and he's going to talk about the local sensors development and deployment. Gideon is an electronics and software engineer and sensor IoT engineer at Sensors.AFRICA, and he's also from Code for Africa. That's where Ahmed was from. So Gideon, could you please take us?
Thank you, Dorothy. Good afternoon, everyone. So I don't need any further introduction, but I'd just like to tell you what Sensors.AFRICA does. So what we basically do is develop air quality monitors and other monitors like noise monitors. So involved in the hardware development and also implementing the data infrastructure. Next, please. So my focus for this presentation will be about hardware development scene in Africa. And I'd like to pose a question to you. How many of you in your homes have consumer electronic products made in Africa. The silence speaks a lot, but maybe I can discuss why that is not the case. Of course, we are not known as a manufacturing powerhouse. This is because, especially also on consumer electronics products, we also have like few companies specializing in manufacturing processes to produce the refined quality of your daily electronic products. When it also comes to the context of hardware development or electronic development, there's a limited availability of electronic stores where they sell these electronic components. So next, please. All is not lost. If any one of you here is interested in developing their own sensors, which are especially in air quality monitoring, since that's what brought us here, this has been a lot of initiative, and it's growing in Africa. So I'll give you a guidance on what you could do. So before you make electronic products or an air quality monitor, there are several stages in hardware development that you should follow through. First of all is having a prototype. And a prototype is basically some sort of a crude implementation of what you want your final product to be. So you want to go from a crude prototype to a working prototype and then to a final prototype. As you can see in these photos here, we have examples of prototypes. This one close here is probably where you will start with. This is just a simple puff board that has holes in them, and you can manually connect these components. If you have the skills, you can go further and implement a DY PCB. A PCB is a printed circuit board. Most people know it as a motherboard from your electronics. So you can be a little bit creative. When going into enclosure prototyping, you could use something like this. These are some of the enclosures that you can find easily in the electronic or electrical shops. Do a little bit of improvising, fix these boards over here, and then test them out in the field. Next, please. So now if you have been satisfied with how your prototype is working, you want to produce the final product or even a final prototype. I know most of you who have been at the AfriCET site, you can attest to the quality of the sensors that have been there. From, of course, our Sensors.AFRICA, AirQo, Clarity, IQ Air, they look good, yeah? You probably want your sensors to be of the same quality. So when it comes to electronic manufacturing, there are some design principles that you must adhere to for your sensors to work well. So this, we call them the electrical and design rule checks, because you need, once you have that final design, you want to ship it elsewhere for manufacturing, and you don't want to make any mistakes over there. So, and it is also important to ensure that the components that you're using, they are in stock. I know most of you have heard about the chip shortages. So it can affect their development life cycle. You need to use something that is quite available. Also, these employees in the enclosure manufacturing, you use the right tools and the right design principles for the desired manufacturing processes. We have a few of the technologies that you can use. 3D printing. 3D printing is what we basically use. It's good for small deployments and rapid prototyping, but you can also use it to make your final product. The other one is injection molding. This is like the most popular one, especially for products that use plastic. It's quite expensive. The initial cost is quite expensive, but in the long run, the prices are quite fair. So this one is suitable if you intend your project to be quite large scale, quite big. So this is what you'll go for.
Sorry, Gideon, I'm sorry to interrupt you, but you have about 6 minutes or give or take 5 to finish. So if you could just like go through this very quickly.
Okay, thank you, Dorothy. So I won't talk about the design principles, but you can see here is an example of a PCB that has followed all these principles. It's easy to fix, connect the ports, it's ergonomically designed, so you don't have to do a lot of gymnastics with your hands. Next. Also here is a picture of a 3D printed enclosure. This is something that you could use, and I won't talk about the standards. You need to make sure that it conforms to some of the IP standards like waterproofing or weatherproofing. Next, please. Next. So I will talk about our experience at Sensors.AFRICA. Next. So in our development life cycle, we have upgraded to industrial designs. We have moved from using modular components to embedded components, and from using those generic enclosures that you can find in the stores to a more refined custom enclosure. I wish I could show you them, that I don't have time, something like this or this. And then, of course, we have experienced developmental challenges like acquiring SIM cards, power issues, and also the performances of our electronic components and replacement components. Next, please. So the solution to this is, for the power, we want to have an alternative power source, which is, of course, solar. And then we want to design for locally available power accessories and switching to more power-saving modules, and also subscribing to IoT SIM cards, which I'll talk next. Next, please. So on the communication technologies, I will talk about, this is also in the context of Africa, or what you could use so that you can get your data from the sensors to your database. So next, first of all, I'll start with the cellular technologies, which is GSM. Africa enjoys a very good coverage of GSM. And this is what you use for your SIM cards. Next, please, or your mobile phones. As you can see from the map here, you can attest that Africa is well covered when it comes to cellular technology. Next. So some of the challenges with GSM for IoT application, and by IoT I mean these air quality sensors, since they communicate with the internet. One is navigating country telecommunication regulations, and it's hard to assess the network strength of each and every service provider, and high data roaming charges. So the solution to this is getting an IoT SIM card. So this is a service that you use one SIM card for every region that is supported by your IoT provider. And of course, there's some factors to consider, which include the cost and also the network coverage of your IoT SIM card provider. Next, please. So I won't talk much about this because they are not quite popular here in Africa, but these are some of the technologies that you need to look into IoT project. That is NB-IoT and LTE. So LTE just means 4G. Next. Another one is LoRaWAN. The implementation looks quite similar to GSM, but the good thing about this is you can actually have control of your network or set up this network, and you don't need any kind of licensing. Next. So there are two deployment options for LoRaWAN, which one is subscribing to a third-party public network or setting up on private network infrastructure. Another cellular network is Sigfox. Right now, it's not quite popular. And as you can see from the map, it's only like about 10 countries that are supported. So the takeaway from communication technologies is that GSM is the most viable option. If you want to deploy to multiple regions, you need to subscribe to an IoT SIM card service provider. And then you can use also multiple communication technologies as fallbacks for in case one fails. And once you have deployed your sensors, it's quite crucial that you monitor these some key parameters, which of course include the sensor data. You might want also to check on the health of your batteries, the charging status. You want to also check the hardware usage or hardware metrics of the physical infrastructure that are like the database server. You also need to monitor the uptime and the downtime times, your API. Next, please. So here is an example of a dashboard that you could use to monitor your live network of sensors. So wrapping up, when delving into hardware development, you need proper research and proper planning. And also, for the sake of your team, you need to create a playbook that will be used in future for reference. So if you'd like to connect with us, and in case you want to learn more about hardware development, you can connect to us through these socials. Thank you very much for your time.
All right. Very brilliant presentation. And now we're going to hear from Dale Okudi, who's an the session is AirQo sensor kit and air quality sensing kit custom designed for low-cost resource settings. And Okidi Deo is a skilled electronics engineer at AirQo. He designs and builds low-cost air quality monitor hardware and firmware. He is passionate about scientific knowledge, sharing, and application to innovate solutions for the African context. Among his interests are low-power electronics design, sustainable energy systems, edge computing, robotics, and 3D printing. Okudi holds a BS in computer engineering from Okure University. Way to go, I'm from there too for my undergrad, and enjoys walks and listening to music. Okudi, could you please take us? And you only have about 10 minutes or so. Thank you.
Thank you very much. Good afternoon, everyone. The previous presenters, thank you very much for giving that. I think it builds up very nicely to this. I'll be talking about the AirQo sensor kit. That is a case study of designing low-cost sensors for the African context for air quality monitoring. In the context of our hardware, next slide. Yes, the context of our hardware, I'll be talking about the features of the AirQo monitor. Weatherproof enclosure that the previous speaker was talking about. You're deploying a hardware product, you need to make sure it's deployable in the outdoor environment. So we featured weatherproof enclosure, battery and solar power to power the electronics. We also use dual particulate matter sensors, SD card storage, very important, like you had mentioned, thank you, and dynamic firmware to add logic to the hardware. Next slide, please. So this right here is the sensor kit. Right now, we are the monitoring scope of the AirQo sensor kit is particulate matter, PM2.5 and PM10. We also monitor relative humidity and temperature. With a 5V to 12V DC power supply, we can power the device, or using 6-watt solar panels when deployment. The backup battery is an 8.8 amp hour battery to ensure that you can have an extended runtime in the absence of solar power. That's our current consumption during transmissions in power save mode and extended sleep modes. We're also using 2G GSM communication for internet access, which they've already elaborated has the widest coverage in Africa. And we also add GPS and GNSS to localize the data from the sites at which the monitoring is being done. Next slide. Design features. So I'll go over the design features of the hardware. They already elaborated that to do a hardware product, you need to research and design your product. And this is a block diagram of the AirQo monitor, showing how the power and battery, the sensors, the communication, and the integrated processing comes together to give you a hardware product. On the next slide, the hardware needs to have firmware to add life to the hardware. We talked about smart solutions for air quality monitoring. So firmware adds the smart to developed hardware. So the AirQo monitor has a dynamic firmware with those following capabilities: adjustable upload intervals from 1 to 15 minutes, configurable power parameters for each sensor, which are stored in EEPROM in case you lose power and startup. We also have local data storage in case of failed transmissions, and power saving routines in the firmware that can switch parts of the hardware on and off to have extended battery performance. We also add real-time clock to have a timestamp, an actual absolute timestamp on every data point that is collected. Next slide. And the device casing, applying additive manufacturing like 3D printing, which is, I think, very important for hardware development. We're able to iterate over a number of things. So this is a 3D printed enclosure for the hardware that is designed. And what we added was a built-in filter mechanism to the to the enclosure, because in deployment of these particulate matter sensors, after a prolonged exposure without a filter, they get clogged, and that reduces their runtime in the field. An additional filter makes sure that we have an extended operation time after deployment. Next slide. And of course, testing and validation is very important. After developing your hardware, you need to make sure that it is working in, it's adhering to established standards. So I think Dr. Ross already mentioned that you have to test these devices against a reference monitor or with where you test them together. So what you look at there is a co-location infrastructure of a number of AirQo devices being tested together to ensure that they are working in unison. And this is just hardware level tests to ensure that everything is operating all right. And the next slide is a look into the data from the air quality monitors after collocation to look at how strong or weak the correlations from, the data correlations from the sensor are. And that will help you iron out any hardware level or firmware level issues that you might have. We also do field calibration with reference grade monitors. Most notably, of course, the beta attenuation monitors in Kampala, with the UNEP in Nairobi in US Mission, and University of Ghana, where you visited yesterday. These are all the components of the AirQo installation. In the AirQo local sensor kit that are 3D printed and all locally manufactured here, and I think quite accessible. Next slide. And of course, deployment and coverage. So the sensor kit is designed to be easily deployed with a minimum bill of materials that are already available. With just simple nylon cables, you can set up the sensor kit in whatever site you've selected. And he mentioned IoT SIM cards for communication, and the sensor kit uses IoT SIM cards to enable communication across boundaries, giving us that wide network coverage, as you can see on that map. And the next slide. Network management, of course, for a high resolution network. If you have a number of sensors, then you have to have sufficient ways of managing your network. AirQo Analytics right now has around 200 or more devices deployed across the continent, as elaborated on that map. And network management lets us keep track of all the parameters he had mentioned earlier on: uptime, the maintenance, sensor correlations, your battery performance, and such. This is a graph showing sensor correlations of a device that's already deployed in the field. Next slide. And of course, maintenance. So we have quarterly maintenance scheduled for local sensors, being because they're deployed in outdoor environments, the sensors can get clogged with dust. And so quarterly, or at least quarterly maintenance is important to ensure that everything is still operating optimally. They will need cleaning. Batteries are consumable. After a period of time, you might need to replace your batteries. And of course, firmware is always evolving, so firmware updates are very necessary. And of course, after the data is collected, you have to be able to access it through a dashboard, which he mentioned. You can access the data from the sites. A very powerful API for third-party integration. This is an interesting case of NBS in Uganda using the API to access air quality data. And of course, the mobile app, the AirQo mobile app that can also give you access to the air quality data downloadable on your phone. Next slide. Yes, I think that is all for us today. Thank you very much.
Thank you, Dale. And just to have a recap of the session, it's been, we first heard from Ahmed, who really talked about like having that local contextual knowledge on where you're going to place your monitors, which helps in issues to do with access to data and just being able to keep having more monitors in place. Just, having that knowledge is very key in where you place the monitors and also later accessing the data. Very key, especially when you're working in places where you have issues with electricity, and so having the solar in combination with the monitors you're setting up is very important. And then we heard from Gideon, who was really talking about the hardware and how to build these monitors. And also he seems to say that for those who are interested and you want to know how to do this kind of work, you can approach them and they'll be happy to train you on doing this. And then lastly, Dale, who's also still, it ties back to what Gideon is saying, really having the expertise to build these monitors and also being able to access the data. But I think the overarching theme from this session has been really having the local contextual knowledge on where you're building these monitors and where you're placing them, installation, because then it ties back into how you're going to be able to access these monitors to be able to do the maintenance and not having to like fight with the customs and also the delays that come with shipping things across the continent. And so I want to hand over this session now for the Q&A, because I believe most of you have questions regarding what we've been talking about. And so I want to hand over this session back to the people who are in the in person, so we can hear from the rest of the groups what the questions are and what they want to weigh in terms to do with air quality monitoring in that space in Africa. So I'll hand this over to IQ. Please take over. Thank you.
Thank you so much, Dorothy. And thanks to our panel, very young people. I think Rose is also young at heart. So we're also happy to have Subu online as well. So the idea now is to make this less of a panel discussion, more of an interactive session for you to ask of our colleagues here any questions that you may have. It's also an opportunity for you to share your experience as well. So we are looking at what are the enablers. It's difficult, yes. What we are trying to do here is difficult, but we've done it and we are doing it. So what are the best practices? You're also free to share those with us. So we'll do this in 3 rounds. I'll go to the room, take 3 questions. I will ask Becky and Dorothy to monitor the online community. We'll come back to you for any questions from online, and then we'll come back to the room. So anyone who has any questions, this is your chance. You can also share your experience with us, what has worked for you. And please don't bombard our young people with difficult ones. They are the future of air quality.
Thank you very much. Let me begin by appreciating all the air sensors manufacturers in Africa. It's a novel activity and engagement. But it's one thing that worries me, and that is that most of these components that are used are imported. And they are subject to the same conditions that they were manufactured, the same conditions that are used to manufacture all other sensors. I do not see how compatibility with African conditions will differ between those ones, I would say, assembled in Africa and those assembled out there. If we do not manufacture the major components, the diodes, the resistors, transistors, or even the chips, I think it's more of assembling them. I'd like to see an Africa where we can develop those basic components, which are the sensitive items that will make for compatibility with our environment, the climate, and all that. That would just be my comment on the matter. I think I want to challenge all of us to look further. We need to go beyond this. Thank you.
Thank you so much. There was someone else. So let's try and see how we can develop some of the components here. Thank you for that.
Thank you very much. I've had some few experiences. They were not so palatable. Some of them were at the top level, the ministerial level. Some of them were at the local level. For the local level, I may want to, pardon them. I remember you went surveying, you were given a whole pickup to go around to look for places to mount some instruments. And you get to these community people and they are so suspicious. And they start harassing you. And they start, whispering. What are these people up to? and that kind of stuff. But I thought that is only limited to the local people. You enter a minister's office and he's so suspicious about, sorry to say, Europe or America, and that maybe you are an agent and you are coming to mount an instrument, to be communicating, and that there are some secret, some hidden, components within the instrument, an in situ instrument to take data just at a site. It has nothing to do with, there's no wireless, nothing. But they are so suspicious. I know some of the, people from government institutions are here. So I don't know how we should address this issue, because people at the very top level are so suspicious about what. So if somebody will say, if Go rust, what will Ion do? So if the top person to understand you is having challenges with your setup, your instrument, your sensors, and it's raising a lot of questions, I don't know. People within the government institutions who are here, maybe they can, explain to us why sometimes they want to, be a bit difficult in some of these things. I know you want to, sometimes they will say, for national security reasons, certain things within our country should not go out. So for national security, I don't know to what extent, measuring air quality has to do with national security here. I've been frustrated in some communities by, even people within government offices. You go to them and they are like, what is this about? Tell us. Sometimes you have to carry the instrument, go to them and show it to them. Still, they are suspicious. Please, how do we solve this low confidence gap? Thank you.
Thank you so much. Anyone else?
Good afternoon, everyone. I would like to direct this question to Dr. Rose. I had an experience trying to, you mentioned the importance of co-location of local sensors with reference grade instruments. I tried setting up some local sensors with government instruments in Nigeria, and from my findings, I couldn't find any. So I'm curious, is it that they are there and unaccessible, or I don't know, or they are not functioning?
Thank you so much. So I'll go back to the panel and I'll try and phrase those two as questions, and the last one to Rose. So the first one, if we can have locally manufactured, is there anything in your solution that comes, locally? If you can speak to that, each of you. And how have you had any challenges with accessibility of your solution as Sensors.AFRICA, as AirQo? If you can say a few things about that.
Well, I totally agree that we should make an attempt of producing these components locally, but it's a huge challenge. It needs a lot of support from the government, and keep in mind that this is a very cost-intensive undertaking. So I don't know whether it will make business sense trying to compete with other leaders out there. So maybe an approach is collaborating with these manufacturers to set up plants in Africa. And that boils down to, of course, government support. In Kenya, I will speak, we have started those kind of collaborations. There's an institution called Gearbox that actually has a PCB manufacturing and assembly plant in Africa. I think it's a first in Eastern and Southern Africa, if I'm not wrong. Yeah.
Can say something about, there was a question addressed to you from access to high reference stations.
Okay, I think I'll answer the two. why the people at the top find it difficult to understand. To solve that problem, you have to carry them along from the scratch. So you work with them and let them know what you want to do, even before you acquire the sensor. You carry them along from the scratch, you know, they will need those data for policy making. So you just bump in on them at the middle of the work is difficult. If you carry them along from the scratch, they will have interest and they want to know what will come out of it. So they will work with you. That makes it very easy. So you first of all have to explain to them, let them have the awareness, create the awareness and tell them to work with you for this project, for this reason, then you will not have any problem. The second one about reference monitor in Nigeria. You said you tried to co-locate. I don't know where you went to co-locate. In Nigeria, we have at this moment just 2 reference monitors at the US Embassy, Lagos, and also Abuja. So if you're looking for reference monitor to co-locate your local sensor, those are the places you will go to. So you will have to contact them and see if they will approve. But also, there are some new reference monitors that are also coming into Nigeria, University of Lagos in particular. So hopefully this year, if you want to co-locate, you can come and co-locate there. Okay.
Deo, would you have anything to share on your solution acceptability?
Yeah, thank you very much. Yeah, I guess air pollution or the effort to monitor air pollution is one that obviously integrates people in it. And as much as you have the devices, you're still going to have people, right? They're the ones going to consume the data. They're the ones going to show you the site. So if you're going to increase acceptability, you have to include them from the grassroots, co-create with them, right? I think that was the word they were used. So they are included in the entire development of the issue. Yeah, we've observed some of those issues. You go to a deployment, and if people have not been reached out to, then you're going to shock them probably with this device that you're carrying. But if you take an approach that is inclusive, probably with the leadership, and in AirQo, we're taking an approach of working with the local government units to select those sites of installation, so that when you're doing the installation or maintenance, you're confident that the people are already educated about the installation that you're doing. Yes. Also working hand in hand with institutions of learning, say schools, or even higher institutions of learning, because that is where this knowledge is going to be passed to the masses. Yes, I think that will increase the acceptability of the solutions that we are proposing here. Yeah.
Thank you so much. I would like to see if Subu is with us.
Yes, Subu has a comment.
Yeah, I was going to come to Subu. Do you want to comment on this first round of questions, Subu?
Yeah, thanks. Thanks, Victor. I think I would just say this about reference monitors. So I think there isn't a huge market for reference monitors. I think in any country, you currently have like 0 reference monitors. So if you're going to have, you're not going to start a manufacturing facility for just 5 units or 10 units. I just found out that, for example, Ecotech, which makes a lot of gas analyzers that are certified by the US EPA, has moved its manufacturing completely to India. The BAMs that are manufactured by Met1 are also now being manufactured in India for the entire global market, right? And so I think that makes sense, because when you want to manufacture such an expensive instrument and you're maybe selling 100 units a year, it doesn't make sense to start a company in every country when you're selling only 5 in each. So I'd just like to reiterate this point that that I made earlier, that if countries want to reduce the cost of air quality monitoring, number one, they could actually try and reduce import duties, for example, considering that air pollution monitoring is an essential public good and air pollution is a huge public health risk. So that's number one. Number two point is that for gas analyzers, you also need a lot of calibrated reference gases. And I think South Africa does have that facility to provide reference gases as well as distribution of these analyzers. I don't know of a lot of other African countries that have these certified calibration gases. I think working towards that, I think would be the next step. Thank you.
Thanks, Subu. So Becky and Dorothy, do you have any questions online? Maybe one or two.
No, I don't see any questions. We'll let you have any. Thank you.
Okay. So we still have about 6 minutes for a second round of interaction in the room. Desmond, I see you. Let me just come over to you. And anyone else?
Thank you very much. It's just a quick kind of feedback to the question that my brother here was asking about considerations. You may want to go and mount a sensor somewhere, and then you would hear that, oh, it's a security zone. Sometimes we, as researchers, are eager to mount, but in every jurisdiction, there are some rules and regulations. And so it's extremely important to engage the local authorities in those jurisdictions to understand what the permitting regimes are and the like. There's an example here in Accra where a sensor was mounted close to a place that the local assembly and everybody thought it was a good place to have a sensor. There's a lorry station, there's a hospital, there's a traffic point. So a researcher's dream location, but it's also a security zone. And so the assembly may say it's great to mount it there. And after a couple of weeks, when the security personnel also do their own inspections and see something which is not supposed to be there, in their opinion, they also go and just take it off. If you are lucky, you get to know that someone informs you that it's gone off, or you see the monitoring on your dashboard that something is amiss. If you are so unlucky, you may just not hear anything at all. And so I think it's important that we should be mindful of that, because in some jurisdictions, that may lead to the whole closure of your research project, because the authorities may think that they don't know about it. But there's also an opportunity to kind of build a knowledge base of the authorities to understand why that research is going on and why the monitors are also important there. So just a little bit of a reaction.
Anyone else? I think that feeds very well into the acceptability angle and why we need to involve them from the start. So thanks for that, Desmond.
Sorry, it's a technical question. Which protocol you have used to transmit data from sensor to your servers? And what was your challenges and those things? If you want to answer, you can answer. If it's your trade secret, you can avoid it. I think so. I have done.
I was moving the mic around actually.
By protocol, you mean like a communication technology?
Yeah, is it a HTTP or MQTT or what?
HTTP, in some instances, MQTT. So, but the mean is just HTTP, HTTPS. Yeah. And when I talk about the challenges, maybe let me talk about the communication technologies. And this is on the GSM aspect. We have like different, since you're getting this service from a cellular service provider, you find they have like different policies of the activation of your SIM card. So we mainly load our SIM cards with data. We don't use them for communication, for voice communication. So after subscribing to data bundles, you find after 3 months, they have deactivated your SIM card. And now they say that you're not using it, but you have been using it. You have been loading data bundle. So that's one thing, and we are trying to move away from it. And I also talked about the solution, which is using an IoT SIM card. So this will, of course, help us, not go through that whole difficult process of communicating with the service provider. And also it provides a good avenue for deployment in multiple regions. And with most IoT service provider, you don't have to worry about network issues. If one network service provider is down, they will easily switch to another available one. I hope I've answered your question. You can keep them coming, please.
Do you have a question? Okay, just to add to what he has said, concerning the issue of your SIM cards being disconnected when you've not used them for calls, you could actually go to these network service providers. They have quite a lot of packages that they offer, depending on need. For us in Nigeria, we work with Airtel, and there's something they call bucket data, where they link quite a number of SIM cards to just one subscription, and it's only for data. They don't mind if you don't make calls with it. So far, you have data being transmitted from those SIM cards. They work fine. And when you're loading your bundles, you just have to give a call, make a payment, and all your SIM cards have data. It's as simple as that.
Thank you for the opportunity given. Now, I want to say something on what my friend has said concerning taking permissions before the installation of sensors. I remember vividly when I wanted to deploy one of my sensors in one of our airports in Nigeria. The man I met said, "Oga, what do you want to do?" I told him, "Shebi, you are having my letter with you." He said, "Look, that man is a deputy governor. Look, this one is a minister. The people who are sitting inside the airport. Now, if you install and your sensors is telling us that the airport is polluted, what do you think will happen to us?" I didn't know what to say. At the end of the day, it was not approved. Now, another scenario I encountered, installation of my sensor in one of the institutions in Okure, Ondo State. It was installed today. Next morning, I wanted to go and take data. It was gone. So from security experience, they now said the man that installed was the one that came to collect. So at the end of the day, the security men, the policemen took over and the sensor was returned. That's a sad experience I had. Then the third one is this. The area I wanted to deploy, I have electricity, manipulated sensor, but in that area, there is no electricity. So I wanted to convert from AC to DC. The unfortunate thing, the person that wanted to do it, well, I don't know, but the sensor is not working as I'm talking, which means it has gotten damaged. So in what this one, the third one I want to ask question on is, in such a situation, how do we convert from AC to DC without damaging the sensor? So
I would say that's quite very easy. You don't have to really do anything so technical. First thing I would ask is what sort of port or connector does your sensor use? Quite a lot of sensors have very common ports that are easy to get. We have male and female connectors, just like your phone. On your phone, you have the female port, while your charger, the head of your cable for your charger, that's the male port. So once you know that, you could easily maybe go online, look for the male connector, because I'm expecting your sensor to have a female connector. Then you could actually buy, you look for the power rating, if it's 5 volts, you could just get a regular adapter, just like the ones you use to charge your phone. And you just get one that's going to connect your charge adapter to the male connector that you have for your sensor, and that should work.
Yeah, thank you very much. I think it's also important to assess the power sources that are available for your installation site. But being most of the sensors that we're deploying are outdoor deployments. That's why I think solar power is de facto source of power for these installations. And we also make sure that the device has a seamless integration with the site that you're installing at, so that it doesn't attract a lot of unnecessary attention to itself. We also size the solar panels so that if they're tiny enough, someone cannot take them away or he will not have incentive to take them away to like power his other electronics in case of vandalism. If the solar panel is tiny enough, then there is no reason for a person to remove them. But if your design needs very high power and you need a huge solar panel and you deploy it in a particular location, then I think it's very obvious that a person will take that away and use it for his own things. Yeah.
Thank you so much. So we have a bit of time. I think the coffee arrangements are being made. So we'd like to welcome Professor Dr. Engineer to summarize this all for us. I hope we haven't missed anything online, Becky and Dorothy, before.
I think the caption was closed. It just opened, so I believe people had questions, but were not able to take them. I'm sorry about that for everyone who's online. And Victor, before we go to engineer, and maybe as this is something engineer could help us, and Dale, it seems like, just for me to add to this conversation, it seems like most of the questions around like accessibility to communities and things like that, engagement. AirQo seems you have done a very good job. And I wonder if AirQo has a handbook that they could share. And if you don't have a handbook that you could share, Dale, is it something that you think we could explore next year in class with the students, and have something that you could share with everyone who wants to deploy their monitors in areas that are very difficult to get in, and also just in the communities in general? So thank you.
Right. Thanks. Thanks, Dorothy, for that great question. And thanks to our moderators, Deo, Dorothy, Rebecca, and of course, our Victor and the panelists here, Dr. Subu, Professor Rosa Rani, Usman, Gideon, and Okedi. Yeah, so maybe just briefly to speak to the comments that Dorothy has stated before I come to summarizing the session. Yeah, I think the issues that come to, how we engage with the communities is important. I think we should have a rubric somewhere. I just need to check with my team, but we should have a rubric on the common practices on how we engage with communities, and what you can perhaps share with the different, parts of the continent. But I guess this might vary depending on the community, but I think the issues have been raised, like the issues from either suspicion from communities or government, this constantly, come up. Even the prioritization of air quality monitoring in cities, I think this constantly come up. I think one of the things that we see in AirQo is that you really must engage the local authorities. I think as was mentioned here, yeah, you come as researchers and you have like your designed ideal experiment setup and you want to follow that. But then for the moment, you need to step back a little bit and understand that the community you are going into, there are structures that are in place, there are leaders that are there. So even when someone gives them access to install at their premise, a local leader within the same community can actually decide to deny you access, because some of the community leaders, they feel you've surpassed their powers if you come and start engaging their people under their leadership without engaging them. So it's very important that you map out who are the stakeholders in the space, meet with the leaders, and once the leaders are in the know, they actually will help you to do most of the groundwork. They will help you to mobilize the right people. They'll provide security and so on. I remember one of the first examples we did. We used to install, we still do, devices on motorbikes. We call them borders in Uganda. I think we call them Okadas in Lagos. How do you call them in Accra? Okadas, yeah. So we used to install these devices there, and one of the things that the riders used to say is that they're getting a lot of questions from the passengers, but also some of the riders were getting issues with security being allowed into certain places when they had the devices on the motorbikes. And then we had discussion with them. So initially we are just putting devices on the motorbikes without actually even empowering them on how the device is helping them. So we had a meeting with them. We did a session. We did a workshop. We brought the border riders in. We brought a medical doctor in, and we tried to explain the dangers of air pollution to them, their passengers, and so on. And they were empowered. And then we also looked at the design and say, well, as Okedi was saying, instead of having a device maybe in this bright color and putting it on a motorbike, everyone is gonna be looking at what is this thing. So we tried to do the design on how this could blend into the environment, but also ensuring that whoever has the device actually knows what the device is about. So the community person does not have a device, and then the community leader asks, and then the community starts saying, oh, that device was installed by some researcher, from somewhere. People are going to raise a lot of suspicion. Yeah, but I think it's a good point, Dorothy. It will be good to definitely document all those experiences and see how we can cascade them across the different research communities. So back to session summary. My name is Engineer Bainomugisha, and really pleased to summarize this session. I took a lot of notes, but I'll just try to keep it brief. Just as a reminder, the session objectives are around tools for sensor network management and best practices on how to manage these sensor networks and make them sustainable. And again, thanks to our moderators, the Okure, Professor Rebecca, Dorothy, and Victor, and of course our panelists here. So the session started off with a presentation course from Dr. Subu, who talked about how we can fill air quality data gaps using local sensors and with experiences from AfriqAir. I think there's been a lot of work done through AfriqAir in terms of extending sensor network across the continent. So thanks to the work being done there. And I think you also emphasized the need that as you're setting up the networks, you need resources, that's funding to do the maintenance and also manage the practical logistics, for that, as well as, putting some emphasis in terms of data management tools. I think you mentioned about some works going on in terms of the open source data management tools coming up. Dr. Rose Alani did give us regional perspectives, particularly around air quality funding. We kind of see this graphs which seem to be, increasing, reducing. So maybe we need to see how we can, stabilize that. And of course, also looking at possibilities on how we can encourage funding within the government. I think what we see is that the local sensors, they seem to also help us to make the governments prioritize this issue. So hopefully maybe the question is, how can we leverage local sensor data to increase priority in funding for this space? There was a discussion, I think it keeps coming up around tax waiver, importation, and so on. I think we've all faced this issue. Every time you want to import an equipment, you have to, see how you can reduce on the cost of, the taxes that you have to pay. I remember when we, bring in one of the reference monitors, we spent a lot of money on it and the taxes were quite high. And I was trying to engage the customs in Uganda, how they can deal with this. And then I actually found that most of the countries are signatories to the UNESCO Declaration of 1976, which was signed, I think, in Nairobi. And it states that education and scientific materials ideally should be exempt from tax. So I printed that and I went to the customs and asked them, can you please exempt me because the declaration is this and Uganda is a signatory to that. Unfortunately, they were able to accept, but I know this discussion might be different depending on the country you're in. Usman did, of course, introduce to us about the considerations for, setting up networks, unit objective, the sites, the work plan, and so on, and many other considerations that were repeated later on in terms of the infrastructure and so on. And Gideon, of course, walked through the kind of step-by-step process on how we can, do it yourself sensor development, which was, later further contextualized by Okure with the specific use case of how that's being done at AirQo as well. And then the discussion around the suspicion and engagement with the stakeholders did come through that. But I think what came out clearly as we were concluding is that we need to ensure that we have buy-in from different stakeholders. So once again, thank you so much and wish you a good evening. Back to you, the moderators.
Thank you, Engineer. And that's a nice way to take us to the coffee break. Can we clap for our participants, moderators, speakers again? Yes, so we'll share these resources. So we'll keep the discussion ongoing and looking forward to the next session.